A very good morning to all of you. So in the today's class of the engineering thermodynamics, we are going to discuss about the various processes. That is, how can we find out the change in the internal energy, change in the enthalpy, and pressure, volume, temperature relationships in constant volume process, constant pressure process, and constant temperature process. So these are very important one while you are solving the numerical problems. So the same thing I have listed here. So why we have to study all these different processes. So it is important to know that the PVT relations and work transfer, heat transfer, internal energy, and enthalpy of constant volume, constant pressure, and constant temperature processes. So these are very essential in solving the numerical problems in engineering thermodynamics. So the outcome of the lecture is, so you have to solve some problems based upon constant volume process, constant pressure process, and constant temperature process. Now let us discuss about so that is the non-flow processes or the closed systems. How can we apply the first law of thermodynamics to the non-flow process or closed systems? So let us consider first of all the reversible constant volume process. So constant volume process is also known as isochoric process. So how can we represent the isochoric process on the PV diagram? So that is on PV diagram, whenever you are drawing a vertical line, so that is on this vertical line, you take any point, So here we are able to say that V1 is equivalent to V2. That is, it is basically undergoing for the several intermediate states. So whenever you take any point on this particular straight line of the constant volume process, so that is all the particles are having the same value. That is the V1 is equivalent to V2. So here you have to remember, so the constant volume process is known as isochoric process, and how can you represent constant volume process on the PV diagram? So that is important one, that is V1 is equivalent to V2. Now let us go to the first law of thermodynamics, that is the delta Q. So equivalent to delta du plus delta W, or du is equivalent to delta Q minus delta W. So it is a constant volume process. So W is equivalent to PdV. So dV is equivalent to 0. So delta W will become 0. So that is the delta Q will be equivalent to du. But you know that the change in internal energy is always represented as mCV into T2 minus T1. Per unit mass of the substance, it can be written as Cv into T2 minus T1. So that is broadly we can say that, so during the constant volume process, the change in the heat transfer is always equivalent to dash. That is an important question in the GATE examination. So the change in the heat transfer is always equivalent to the change in internal energy during the constant volume process. And similarly, let us consider the next process, that is known as the constant pressure process, which is also known as isoboric process. So in the competitive examinations, they may ask you that during isoboric process, which parameter will remain constant or dash parameter will remain constant. So that is the answer is the pressure will remain constant during the isoboric process. So that is iso, it is a Greek word. So iso means same or uniform. Bar, so because we discussed that what are the various units for the pressure. So bar is the unit for the pressure. So iso constant, bar means is a pressure. So pressure will remain constant during the isobaric process or the constant pressure process. So that is the meaning of the constant pressure or isobaric process. So similarly now, how can we represent the constant pressure process on PV diagram? So on PV diagram now you can see here, so the horizontal line on the PV diagram is basically representing is a constant pressure process. That is, here you can take any point on this 1 to 2 line. So on this 1 to 2 line you take any point. So that is all the molecules are having the same pressure. So that's why the horizontal line on the PV diagram is basically representing constant pressure process. So once again, you go to the first law of thermodynamics, that is the delta Q is equivalent to du plus delta W. So here delta W is not equivalent to 0 because in the previous case it is a constant value. So that's why delta W is equivalent to PdV. So dV is equivalent to 0 in the constant value process. But in the constant pressure process, delta W is always equivalent to P into V2 minus V1. So now you have to substitute the formula of the delta W here, then we can find out the delta Q. So delta Q is equivalent to dH, that is H2 minus H1, that is equivalent to mCp into T2 minus T1. So that is, in the previous case, during the constant volume process, delta Q is equivalent to du, where it is equivalent to mCv into T2 minus T1. But here in the constant pressure process, delta Q is equivalent to dH, that is equivalent to mCp into T2 minus T1. So that is the important observation from the constant value process and from the constant pressure process. Then coming to the third process, that is the isothermal process. So just now I told you that iso means is remains the same or uniform, thermal, that is the temperature. So temperature will remain constant during the isothermal process, which is also known as constant temperature process. What is the governing equation? So because we already studied that out of pressure, volume and temperature, always we have to keep one parameter as constant. Let us say that temperature is constant here. So then we are finding out the relationship between the remaining two variables, that is the pressure is inversely proportional to the volume. So PV is equivalent to constant. It is known as the Boyle's law. So P1 V1 is equivalent to P2 V2 is equivalent to constant. So that is the Boyle's law. So now how can you represent the constant temperature process on the PV diagram? So that is, it is a curved line. So it is a curved line on the PV diagram is basically representing the constant temperature process. So similarly, once again you go to the same first law of thermodynamics equation. Delta Q is equivalent to du plus delta W. We know that du is equivalent to mCv delta T plus W. But here you know that is isothermal process. So T1 is equivalent to T2. So Cv into 0, it will become 0, 0 plus W. So W is nothing but is the integration of the PdV, because we know that isothermal process. So what is the work done? So work done during the isothermal process is nothing but is a mCv into log into V2 minus V2 by V1. So C into log into V2 by V1, that is the work done during the isothermal process. So here we can say that delta Q is equivalent to delta W. Delta Q is equivalent to delta W during isothermal process. So that is, in the constant volume process, delta Q is equivalent to du. In constant pressure process, delta Q is equivalent to dH. In the isothermal process, delta Q is equivalent to dW. So these are the important observations we are able to have from the constant pressure, constant volume and constant temperature. So just you observe the overall gist. That is, what is the, how can you find out the PVT relationships in case of the constant pressure? So pressure is constant, automatically volume is directly proportional to the temperature. So V1 by V2 is equivalent to T1 by T2, or T2 by T1 is equivalent to V2 by V1. And similarly, how can you find out the work during the constant pressure? So it is the P into V2 minus V1. And delta Q is always equivalent to mCp delta T. Per unit mass of the substance, it is Cp into T2 minus T1. And whenever you are having PV to the power of n is equivalent to constant, so what is the value of the n if you want to obtain the constant pressure process? So PV to the power of n, so whenever you are putting n value is equivalent to 0, so V to the power of 0. So something to the power of 0 is nothing but 1. So P into 1 is equivalent to constant. So pressure is equivalent to constant. So that's why what is the value of the index, that is n value is equivalent to 0. When n is equivalent to 0, you are able to obtain constant pressure process. And similarly, just you go to the constant volume process. So in the constant volume process, work is equivalent to integration of the PdV. So dV is equivalent to 0. So automatically integration of the PdV, that is equivalent to is a 0. That is, the work done during the constant volume process or in the isoporic process is always equivalent to dash. It is always equivalent to 0. So similarly, now constant volume is remains constant. So then automatically we are able to obtain the relationship between the pressure and temperature. So P is directly proportional to the temperature. So P1 by T1 is equivalent to P2 by T2, or T1 by T2 is equivalent to P1 by P2. So here in the constant volume process, what is the equation for the heat transfer? That is a delta Q is equivalent to du, that is nothing but mCv delta T. And similarly, when n value is equivalent to infinity, then which process you are going to obtain. So that is, we are able to obtain only the constant volume process. Next, going to the third process is a constant temperature. So PV to the power of n is equivalent to constant. So when n is equivalent to 1, so PV is equivalent to constant. So P1 V1 is equivalent to P2 V2 is equivalent to constant. That is isothermal process or the constant temperature process. So just now we studied that how can we find out the work in the isothermal process. Work is nothing but P1 V1 into log V2 by V1. That is the formula for the work. And similarly, we studied that in the constant temperature process, delta Q is equivalent to delta W. So that's why the same formula will holds good for the heat transfer also. So delta Q is equivalent to delta W. So these three processes only we are going to discuss. In the adiabatic and polytropic process, we will discuss in the next class, because this class is confined to only constant pressure, constant volume and constant temperature processes. So based on this important relationships, now let us discuss about what are the previous gate questions which were asked on this constant volume, constant pressure and constant temperature process. So let us see the first problem. In an IC engine, during the compression stroke, the heat rejected to the cooling water is 50 kilojoules per kg and the work input is 100 kilojoules per kg. That is, he has given delta W and delta Q. Calculate the change in internal energy of the working fluid, stating whether it is a gain or loss. So once again, it is from the first law of thermodynamics, that is du is equivalent to delta Q minus delta W. So already we studied that dE is equivalent to delta Q minus delta W. So once again, the sign conventions are very, very important one. So just you see here, heat rejected to the cooling water. That is the heat transfer from the system. So heat transfer from the system is always negative. So Q is equivalent to minus 50. Similarly, you see here work input to the system. So work input to the system is always negative. So W is also equivalent to minus. So now he is asking us to calculate the internal energy. So that is the delta Q is equivalent to du plus delta W. So just you substitute the values. Q equivalent to minus 50, U2 minus U1, W is nothing but minus 100. So we are able to see that U2 minus U1 is equivalent to 50. So U2 minus U1 stands for it's an increase in the internal energy, and U1 minus U2 stands for it is a decrease in the internal energy. So that's why we can say that is the gain in the internal energy is equivalent to 50. So here is asking whether it is a gain or loss. Because it is a U2 minus U1, we can say that it is a gain. How much it is the gain? It is a 50 kilojoules per kg. It is the gain. So similarly, now you can go through the next problem also. So that is, here we are having the partition wall. So here we are having the gas which is having the property values of the P1 and T1. So that is the container. We are having the container. So between we are having a partition wall. So it is totally is insulated. So whenever the partition is removed, that is saying that how will the first law of thermodynamics conclude the result if partition is removed. So when the partition is removed, so automatically, so delta Q is equivalent to 0, delta W is equivalent to 0 and du is equivalent to 0. So that's why according to the first law of thermodynamics, we are able to say that it's a constant, it is a law of conservation of energy. So like that, we can solve some problems based on this important constant volume, constant pressure and constant temperature process. I hope you understood the PVT relations, work transfer, heat transfer, change in internal energy, change in enthalpy, concepts of all these three processes. Thank you very much. We will meet you once again in the next class. Thank you.